Hello everyone, good morning to everyone. Today my topic about sum of subsets. My name is Ikotam Raju. I am from CSM department at Reason and Ramosan Institute of Technology. Introduction to sum of subsets. The sum of subset problems involves determining whether a subset of numbers can sum to a specified target value. It means a 10, 0, 5, 8, 6, 2 and 4, but sum is equal to 15. The problem is a fundamental concept in combinatorial optimization and has various applications in field like finance and recurrence allocation. Understanding these problems helps in grasping more complex algorithms such as dynamic programming and backtracking. 10, 0, 5, 5, 8 and 2, 4 is sum is equal to 15. Problem definition. Given a set of integers and a target sum, the goal is identify one or more subsets that add up to that target. For example, when a set 3, 34, 4, 12, 5, 2 and a target of 9, the subset 4, 5 is a valid solution. The problem can expressed as a decision problem or an optimization problem depending on requirement. There are various algorithms to solve the sum of subsets problem, including brute force, dynamic programming, and backtracking techniques. The brute force method involves general all possible subsets and checking their sums, which can be inefficient for larger sets. Dynamic program optimizes the process by storing intermediate results, reducing the time complexity significantly. Brute force method. The brute force approach generates all possible subsets of a given set. It checks the sum of each subset to see if it is equal to the target value. While simple to implement, this method has exponential time complexity. Make it impartial to impartial for impartial for complexity. Make it impractical for large subsets. Dynamic programming approach. The dynamic programming method utilizes a table or a dynamic method utilizes a table to store results of previous computer subset sums. This approach significantly reduces the number of calculations by breaking down the problem into smaller subproblems. The time complexity of this method is 0, n. What is dynamic programming? In the figure. Backtracking technique. Backtracking technique is a recursive algorithm that builds subsets incrementally and abandons any that exceeds the target sum. It explores all potential combinations while previewing non-promising path early. This method is efficient for smaller data sets, but it can still experience performance hits for large inputs. In the figure, we see a backtracking diagram. For example problem. Consider the set 1, 2, 4, 3, 5 with target sum of 5. Possible subset that meets the target include 5, 2, 3 and 1, 4. This simple example determines how different combinations can achieve the same sum. Then 5, 8 and 2 is equal to also 15. Applications of subsets. The sum of subsets problem has practical applications in resource allocation, budgeting and cryptography. It is often used to financial planning to determine feasible investment combinations to meet specific goals. Additionally, it plays a role in designing algorithms for various optimization problems in computer science. Challenges in solving the problem. The main challenge is the exponential growth of possible subsets as the size of the set increases. As the target becomes more complex, the number of combinations increases, complicating the search of solution. Finding efficient algorithm to handle large data sets remaining a sufficient area of research in computational theory. Conclusion and future decisions. The sum of the conclusion and future directions. The sum of subsets problem is a classic example of combinatorial optimization that remains relevant today. Continued research aims to develop more efficient algorithm and better understand problem complexity. As the computational power increases, exploring large data sets and more complex variations will pave the way for new applications. Feel free to expand on any of the slides or adapt to the. Thank you.